Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Define stereoisomers. Stereoisomers are compounds that have the same molecular formula and the same connectivity, sequence of bonds, but differ in the spatial arrangement of their atoms. This immediately rules out any type of isomerism that involves different connectivity. Moving on to the next step. A. Configurational isomers. True. Configurational isomers are stereoisomers that differ in configuration at one or more stereocenters or double bonds, example, cis trans, Rs. These are a subset of stereoisomers, so a pair of stereoisomers can indeed be configurational isomers. B. Diastereomers. True. Diastereomers are stereoisomers that are not mirror images of each other, example, cis trans isomers, or compounds with multiple stereocenters that are not enantiomers. They are a valid subcategory of stereoisomers. C. Constitutional isomers. False. Constitutional, structural, isomers differ in connectivity bonding sequence. Stereoisomers by definition have the same connectivity, so a pair of stereoisomers cannot be constitutional isomers. D. Tautomers. False. Tautomers interconvert by proton transfer and differ in connectivity, example, ketoenol. They are not stereoisomers. E. Conformational isomers. False, as a classification distinct from stereoisomers in the strict sense. Conformational isomers, conformers, differ only by rotation about single bonds and are generally not considered true stereoisomers. They are not isolable as separate species under normal conditions. While some sources include conformers under the broad stereoisomer umbrella, in the context of this question and the correct answer being C, A, B, F, conformational isomers are excluded. F. Enantiomers. True. Enantiomers are non-superimposable mirror image stereoisomers. They are a major subcategory of stereoisomers. G. Positional isomers. False. Positional isomers differ in the position of a substituent on the carbon skeleton, which means different connectivity. These are a type of constitutional isomer, not stereoisomers. Moving on to the next step. The true statements are A, B, and F, which corresponds to answer choice C, A, B, F. And for the final step, choice A, B, C, E includes constitutional isomers C and conformational isomers E, both incorrect. Choice B, D, E, F, G includes tautomers D, conformational isomers E, and positional isomers G, all incorrect. Choice D, A, B, C, F includes constitutional isomers C, which is incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.